3 months ago, in the deep water of the tropical Pacific Ocean, a wave nobody could see on the surface began rolling east. It was not a wave of water sloshing across the top of the ocean, the way you picture a wave at the beach. It was a wave of heat, buried hundreds of feet, down, moving silently beneath a surface that still looked completely ordinary. By the time that wave finally reached the surface and broke into the open air, it had triggered one of the fastest, most explosive transitions in the Pacific Ocean's recent history, and it is now actively rewriting the atmospheric pattern over North America in real time. Not next year, not next season, right now, this week. Meteorologists tracking it are describing the current setup using a specific technical term, an atmospheric standing wave, essentially a lock forming in the sky that is about to hold weather patterns in place across an entire hemisphere for months. Let us walk through exactly what is happening, how it got this powerful this fast, and what it means for the weather heading into fall and winter, because the pace of this development has genuinely caught even experienced forecasters off guard. To understand how sudden this shift has been, you have to go back to the start of the year, because the contrast is almost hard to believe. During the winter that just ended, the Pacific Ocean was sitting in a weak La Niña, the cooler phase of the same natural cycle. By February, forecasters were tracking that weak La Niña fading into a neutral state, and the official outlook at that point gave only a modest chance, somewhere around 1 in 10, that the opposite phase, El Niño, would even develop by summer. Confidence was low. The forecasting community was explicit that predictions made in that window of the year are historically among the least reliable, a stretch of time climate scientists actually call the spring predictability barrier, because the ocean and atmosphere are in such an unsettled state that models struggle to see clearly through it. As recently as February, in other words, nobody was confidently predicting what was about to happen. Then, the deep ocean data started coming in, and everything changed. Underneath the surface, an unusually large pulse of warm water, technically known as a Kelvin, wave had been quietly building and moving east across the equatorial Pacific. This is the actual physical engine behind an El Niño event. Westerly wind bursts in the western Pacific push warm surface water eastward and downward, and that warm anomaly propagates along the thermocline, the boundary between warm surface water and the cold, deep ocean, before eventually rising back to the surface further east. By April, sea surface temperatures off the coast of Ecuador, one of the specific regions scientists watch closely for early El Niño signals, were already running well above average, and that shift in confidence was immediate and dramatic. By May, forecasters were describing high confidence that a strong El Niño would emerge over the summer. And on June the 11th, it became official. NOAA's Climate Prediction Center upgraded its outlook from a watch, meaning conditions favored development, to a full advisory, meaning El Niño conditions were confirmed as actually present in the observed data. In roughly 4 months, the Pacific Ocean went from a fading La Niña to neutral to a confirmed and rapidly strengthening El Niño. That speed alone is unusual. What has happened since is where this story becomes genuinely remarkable, because this is not shaping up to be an ordinary strong El Niño. The most recent ocean analysis shows peak warm anomalies in the key monitoring region of the Pacific already reaching or exceeding 5 degrees Celsius above normal, an extraordinary reading. Model guidance from the CFSV2 system, one of the primary tools used by American forecasters, shows this event pushing well past the 2-degree threshold that officially defines a super El Niño, with some projections running beyond 3 full degrees above normal at peak strength. Independent seasonal ensembles are showing the anomaly potentially exceeding 4 degrees by the October through December window. According to meteorologists tracking the event, the current pace of development is running on an even steeper trajectory than previous super El Niño events in the historical record. And if these projections verify, this would rank among the strongest events ever measured. NOAA's own strength probability outlook gives substantial support to this event, peaking in the extreme El Niño category, exceeding even the very strong tier, sometime around late fall or early winter. Here is a piece of nuance worth understanding, because it actually explains some of the confusing signals people have been noticing in the weather already. Not every El Niño event behaves identically, because where exactly the warm water pools in the Pacific matters almost as much as how warm it gets. Scientists classify these events broadly into 2 types. An eastern Pacific event, where the warmest anomaly concentrates closer to South America, tends to interact somewhat less directly with the upper-level winds that steer weather patterns, at least in its early stages, producing a slightly slower ripple effect across the hemisphere. A Central Pacific event, by contrast, sits more directly beneath the atmospheric machinery that bends the jet stream, acting almost like a more direct hit on the flow above it. The latest seasonal data classifies the 2026 event as an Eastern Pacific type. Under normal circumstances, that classification alone might suggest a somewhat gentler influence on North American weather, at least through the fall. But the sheer raw intensity of this event, with anomalies pushing past 4 degrees above normal in the core, monitoring region, is overriding that usual distinction entirely. Meteorologists studying the pattern have noted that, despite being an eastern Pacific event, the strength alone is producing a fall pressure pattern that already looks like what you would normally expect from a moderate El Niño in the dead of winter, months ahead of when that kind of amplification usually shows up. That is the heart of why this pattern is described as exploding into place. It is not just strengthening on schedule, it is strengthening early, and doing so at a pace the underlying science says should not typically happen this fast. So what does this actually look like in the sky above? You right now, this week, as opposed to some abstract seasonal outlook months away? This is where the atmospheric standing wave becomes the key concept to understand. Under a super El Niño, the persistent area of unusually warm water in the central and eastern Pacific forces air to rise over that specific patch of ocean in an essentially fixed, locked-in location day after day, week after week. Rising air in one place has to be balanced by sinking air somewhere else, and in this case, that balancing sinking motion is showing up over the Indian Ocean. A textbook signature of what atmospheric scientists call a modified Walker cell, the Great East, to west circulation loop that spans the entire tropical Pacific. Because this rising and sinking pattern is being forced by an ocean anomaly that simply is not going anywhere anytime soon, the atmosphere above it gets essentially locked into a standing wave, a fixed, large-scale ripple in the flow that then radiates outward, bending the jet stream far downstream over North America. That is the mechanism turning a patch of unusually warm ocean water thousands of miles away into your actual day-to-day weather. You can already see this playing out in the pattern shifts happening across the country in real time this month. Earlier in August, model guidance showed a ridge of high pressure building over the west central United States, driving warmer temperatures into that region, while the eastern half of the country saw a more unsettled, lower pressure tendency. But the pattern has continued evolving quickly, and the most recent extended forecast trends show that low pressure area shifting further east through the middle and latter part of August, allowing a proper El Niño signature to take hold, a ridge parked over the west central states while trough energy deepens over the eastern United States and Canada. That transition is exactly what has been driving the recent stretch of cooler, stormier weather across the Midwest, the Great Lakes, and the eastern seaboard, arriving right on the heels of one of the hottest summers on record for the country, while warmth continues to hold firm across the south, central, and northern tier. This is not a coincidence or an isolated weather event. It is the visible surface expression of that deep ocean signal finally reaching all the way up into the jet stream above your head. Push the timeline forward into fall, and the amplification becomes even clearer. Forecast trends for the autumn months show a well-defined El Niño temperature, signature settling in, with the core of the warmth sitting under high pressure across the northern half of the United States and into Canada, while a more persistent, unsettled storm track establishes itself across the southern half of the country, keeping temperatures there closer to normal rather than following the northern warmth. On the precipitation side, the signal is even more distinct, with increased fall rainfall expected across most of the United States, especially the south, as an amplified Pacific jet stream drags in repeated rounds of moisture and low-pressure systems. Meanwhile, the northwestern United States, the upper Midwest, and parts of southern and western Canada trend toward a drier than normal fall. Forecasters describe this fall pattern as evolving unusually early, essentially behaving the way you would expect a strong El Niño to behave heading into the heart of winter, except it is showing up in October and November instead. And that brings us to the piece of this story with the most direct impact on daily life for tens of millions of people, the outlook for winter 2026 into 2027. The latest projections from NOAA's next-generation seasonal forecasting system point toward a distinct split-flow pattern locking into place across North America. In practical terms, that means a strong ridge of high pressure builds over Canada, acting like a lid that suppresses the deep, bitter Arctic outbreaks that plunge temperatures to nearly 44 degrees below zero in Ontario during the extreme cold wave that opened this same year. Under that kind of setup, seasonal snowfall potential across the northern plains, the upper Midwest, and the Great Lakes trends below normal, a real tangible break from the brutal winter conditions that defined the start of 2026. But that same high pressure block does something else at the same time. It displaces the active storm track southward, redirecting winter storm energy and snowfall potential into the central and southern plains and parts of the interior mid-Atlantic instead, regions that do not typically see that kind of consistent winter storm activity. Here's the part of the outlook that genuinely surprises people once they see the actual month-by-month breakdown. because it defies the simple assumption that a strong El Niño just means a uniformly mild winter everywhere. As the season progresses from January into February, the temperature pattern is projected to shift meaningfully. In January, forecasters project a distinct cooling footprint establishing itself specifically across the southern plains and the Gulf Coast, even as strong warm anomalies continue to hold across Canada to the north. By February, that cooling signal is projected to deepen and expand significantly, with a broad area of below normal temperatures, spreading across the central, southern, and eastern United States as cold air intrusions become noticeably more frequent. So the picture that is emerging is not simply warm north, mild everywhere. It is warm north holding through the winter, while the central and southern and eventually eastern tiers of the country see an increasing frequency of genuine cold snaps as deep winter sets in, driven by that same displaced, amplified southern jet stream dragging systems, and the cold air riding along with them, further south and east than usual. It is worth being upfront about the uncertainty that still exists this far out, because that is part of being honest about how seasonal forecasting actually works. Meteorologists tracking this event are explicit that this outlook will continue to evolve, with updated data expected roughly every 10 days as the picture sharpens closer to the season itself. The distinction between an Eastern Pacific and Central Pacific event, the exact peak strength the anomaly ultimately reaches, and how efficiently the ocean signal continues translating into atmospheric response are all factors that could still shift the details of this outlook in the weeks ahead. What is not really in question, based on the data currently in hand, is the underlying driver itself. This is a rapidly strengthening, potentially record-setting Super El Niño, developing on a faster timeline than the historical record typically shows, and it is already actively reshaping the atmosphere above North America well ahead of its own usual schedule. Why does the speed of this development matter so much beyond the scientific curiosity of it? Because speed translates directly into preparation time, a seasonal pattern that gradually strengthens over many months, gives emergency planners, farmers, utility companies, and ordinary households a long runway to plan around what is coming. A pattern that is exploding into place months ahead of its typical timeline compresses that runway considerably. The same country that just endured its hottest month in over a century of record keeping and that has already spent this year living through both an extreme Arctic cold wave in January and near record-breaking summer heat, is now heading toward a winter where the standard assumptions about what a strong El Niño delivers may not apply as cleanly as they usually do, because the strength of this particular event appears to be overriding some of the more typical, gentler characteristics of its specific type. That combination, a record pace of development on top of a potentially record intensity event, is exactly why forecasters who track this for a living are describing the current moment with a real sense of urgency, rather than treating it as routine seasonal chatter. For the months immediately ahead, here is what is worth actually watching in your own region, rather than a generic national headline. If you live across the northern tier of the country, in the northern plains, the upper Midwest, or the Great Lakes, current guidance points toward a milder, less snowy winter than the past 2 years delivered, a genuine reprieve from the deep Arctic outbreaks that have battered that region recently. If you live across the central or southern plains, or into the interior mid-Atlantic, the displaced storm track means this winter carries an elevated chance of significant storm systems and, later in the season, increasingly frequent cold intrusions. That region does not typically deal with as often. And if you live along the Gulf Coast, or across the South more broadly, the amplified southern jet stream points toward an active, wetter than normal pattern building through fall and carrying into winter, worth watching closely for flooding potential as repeated systems rides that same track in succession. The deeper takeaway here is that the weather patterns shaping your day right now, this week, are not random. They are the surface expression of a genuinely massive, fast-moving signal originating in the deep water of the tropical Pacific months ago, a signal that has now risen to the surface, locked the atmosphere above it into a standing wave, and is actively bending the jet stream across an entire hemisphere in real time. This is the beginning of that process working through the system, not the end of it, and the months ahead through fall and into the depths of winter are where its full amplified effects are projected to arrive. We will be tracking every update to this outlook as fresh data comes in over the coming weeks, because with a pattern developing this fast, the picture genuinely can shift meaningfully in a short amount of time. Subscribe so you catch the winter forecast the moment it firms up further, and tell us in the comments what the weather has actually felt like where you live over the past few weeks. Because with a signal this powerful driving things, the answer is going to look very different depending on which side of this emerging divide you're standing on. Stay tuned, stay prepared, and we will see you in the next one.